I'm trying to
Sweet,
get
good.
on here, but hold on.
Jason, you're sounding like a robot. It's going back in and out. Like I can't hear you very well.
Is that better?
Yeah, that's better. There we go.
We got the anonymous guy and Mr. Roboto.
Yeah.
Mr. Roboto.
So did you guys do all right on the test?
I did
it.
okay.
I finished.
That's
You
good.
finished it? Hey, good job.
Yeah.
That's always important, right?
That's worth it.
Did he cut out for you too?
Yeah.
I'm
You-
better than you, right? So,
Yeah, we didn't understand any of that, Jason. You keep cutting out.
so I didn't fail it at least.
That's good. You just gotta
Yeah,
pass
I
it
guess.
and you'll be good. You'll graduate if you pass it. That's it, right?
Yeah, I guess.
All right. So what do you guys think of this lesson today?
Can you guys hear me?
It's echoey. Oh, there
Yeah,
we go.
I hung up. Hung up. Sorry.
Sorry if you hear a baby. My little girl's sitting with me.
No, it's all right.
Nice.
It's stretching. Oh. She's been having a rough day today, so we'll see if we can keep her happy.
This is so much easier on my computer. Wow. I don't know why I didn't do this earlier.
Oh, you're on your laptop now?
Yeah, why didn't I do this earlier? Come on, guys.
I should have
Welcome
told
to
you.
the
I
welcome to
was
the
on
Big
my
Boys
laptop.
Club.
Dude, I feel like I'm like an actual like professional here. Incredible.
So were you always using your phone before?
Yeah.
Oh man. Yeah, that'd get annoying holding it all the time, right?
Well, I have like a little stand, so I've got it over
Oh.
there, and then I'm trying to do my computer here, and this is so much easier. It's really nice. All right, cool. When you're done, yeah.
All right, you guys want to do some statistics?
Yeah. Sounds good.
Want to do some maths?
All right. Do you guys have any questions or anything?
I'm on a phone call. I'm on a phone call.
Let's see. I don't know if I have any.
I think I'm all right.
I feel like I understand it somewhat, so I think going through the quiz will help.
Okay. All right, I'm done.
Actually, I feel like I pretty well understand it because it seems like it's really just what we've been doing with different words and different ideas attached to it.
Yeah.
Like it's the same math.
I went over it this morning, and I'll be honest, I kind of forget what. Just remind me exactly what did we do again? Like what is this lesson on again?
Talking about the whole null hypothesis and alternative
right.
hypothesis, and then
Okay,
the process of actually statistically finding out if you can reject the null hypothesis or if you fail to reject the null hypothesis.
So like the whole p-value and all that. Okay.
Yeah, exactly.
Yeah, I thought they kind of went over the null and alternative hypothesis in the beginning weeks, but I mean, that's cool. We get to go over it again, so.
Yeah.
And I
Seems
just
like
remember
it's
that
just
from my last class too. So we did that in my last business class, so I remembered it from there too.
Oh, nice. So they talked about that in your business class?
Unfortunately.
At least
yeah,
it's-
but now you know it already.
Yeah, it's not brand new.
Refresher.
Now you can teach us.
Yeah, I don't think that's gonna happen, but we'll try.
All right,
My
cool.
strength is not math. You give me something to write, you know, that kind of stuff. History, I'm good with that. Math is not my strength, unfortunately.
Yeah, yeah. All right, I'm hitting
Let's try
start.
this quiz.
Yes,
Lesson 9?
I want to begin.
Okay. I guess we could take turns if you guys want, and I'll start, and we'll go from
Okay,
there.
I'll go next.
All right.
Okay.
Same order then as last time. I'm after you, Bryce.
Okay.
Sweet.
3 says, a hypothesis test consists of 2 hypotheses, the null hypothesis and the alternative hypothesis. Which one represents the status quo? The null, right?
The null.
Or maybe it's the true hypothesis. Just kidding. Okay.
Which hypothesis involves equality? That's also the null. Correct?
Equality.
I think so. I remember one of the videos it was talking about that, and then he kind of said, "Oh, but we'll get to that later on." Like if there's 2 sample groups, I don't know. I'm guessing it is the null, right?
Yeah, because this section is about having a known sigma, which, from what I understood, meant that we basically do that we're trying to validate if it's correct or not.
Right.
So, like the example they had in the book was of the weight limit of the boat. And so I think that it's the null hypothesis, because what it's saying is it's that whole thing where it's what was it called? It was like the left-sided and the right-sided alternative hypothesis.
Right.
And then you had
the double
both-sided hypothesis, which was not equal. And so if it is equal, it means it's the null hypothesis, right?
Okay. Yeah, that makes sense. Let's do that.
All right, number 5. The p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer question 5. When computing this probability, which hypothesis do you assume to be true?
The null, correct?
The null, yeah.
I believe it's the null.
Yeah.
Okay.
Any objections?
No, that sounds good. 6 says, suppose the null hypothesis is 10. Use this information to answer questions 6 through 8. So, which of the following represents the alternative hypothesis for a 2-tailed test? So, I think that's the equals / sign.
The not equals.
Yeah, the not equals. Yeah. Yeah.
And then 7 is which of the following represents the alternative hypothesis for a left-tailed test? So left-tailed, does that mean that the value is supposed to be less?
Left skewed, right? It's like a left skewed, right?
So let's see. So I'm thinking of the applet where the left side, the far left side, would be shaded in, right? So,
yeah, it would go like the point. Yeah. The left side would be shaded on the applet.
Okay, and
meaning that it's taller on the right side and it gets smaller on the left side.
Okay. And,
right.
Well, here, hold on. So when we look at the applet, the mean in this case is the U sign, so that would be greater.
It'd be over here.
Than.
So the tail would be over here, right? So it would be, it'd be greater than it'd be greater than
the sample or whatever. The number 10 in this case.
Yeah.
So is it U is greater than 10? Is that the right one?
Mean is greater than 10?
Yeah. Or no?
Perhaps.
Because I'm trying to imagine this on the applet, like, because if
Oh, here we go.
huh.
Says our alternative hypothesis can be written as, and then so in the textbook, well, let me show you what I'm talking about. Okay, here's what it says in the book. Can you see that?
Okay.
So it says the two-sided hypothesis or the two-tailed means it's not equal. The left-tailed means that the mean is less than the value that is less than the null hypothesis.
Okay.
And then right-tailed means that the value the mean is greater than.
So it's open to the 10.
Got it. Okay.
So it would be the second one on.
Yeah, mine's the second too. So it's U is less than 10.
Yeah.
Right? Okay.
The point is to the 0, to the U, right?
Yeah. Mhm.
Yep.
I think Bryce. I think last week on Tuesday you had a different test. It was organized differently on yours, right? Is it the same in yours?
Yeah, mine's different than your guys's.
Yeah.
That's weird. Why they do that? It's like, it's just kind of weird.
Yeah, I don't know what's up.
Oh, I'm up again. Woohoo!
Number 8.
All right. Which of the following represents the alternative hypothesis for a right-tailed test? So that would be the point is towards the 10 now.
Yes.
Towards the 10.
The third
so that third.
Michael.
Yep. Okay. The outcome of a hypothesis test is determined by comparing the p-value to the level of significance, or sigma. Use this info for questions 9 through 10. So, which relationship would result in failing to reject the null hypothesis? Hold on. So
that's it, sigma or alpha.
Oh, is that alpha? Yeah. Alpha.
Because it's basically saying, so alpha is like our level of significance, so it's saying the p-value has to be less than 0.05 or something.
Yeah.
And if it's greater than, then that means that we are failing to reject the null, so that means that we can't assume the alternative.
So this one would be p-value is less than alpha?
It should be greater than. Because if you're failing to reject the null...
Oh, gotcha. Okay, yeah. I read that wrong. Okay. So p-value is greater than...
It's all very confusing because it seems like there's a lot of like triple negatives going on here.
Yeah, it's like, just say it the simple way, you know?
So is it 2 or 4?
On mine, it's the 4. P-value, and then is greater than...
The point is to the p-value.
No, the point is toward... Oh, no, the point is towards alpha, the fish-looking thing.
Oh, so it's number 2 then, Michael.
Oh, well, on mine it's the 4th. I think ours is different on this one.
On mine it's the 1st.
Oh, wow.
Okay.
So p-value, and then the triangle is opening towards the p-value and pointing towards the A.
The A, alpha. Okay.
Yeah.
I gotta close this door because I got kids getting baths. Sorry. Super loud.
Oh, my turn. Sorry, number 10. Which relationship would result in rejecting the null hypothesis? So that should just be that the p-value is less than alpha.
Yeah. So
points to the p-value.
Is alpha always 0.05, or is that just for this class, or is that standard?
It seemed like it was per problem. So like if he were to give us a problem, he'd tell us what alpha was.
Okay. Just the problems they gave us just happened to be that.
Yeah, as part of the process of this whole thing, one of the steps is determining what alpha is.
Sure.
And he doesn't say we actually have to determine it. We're just supposed to kind of be like, all right, 0.05 is what our level of significance. I mean, it's basically saying how sure do we have to be?
Okay, to reject it.
Now it's just a number that sounds like it will be given to us homework-wise and test-wise.
Yeah.
Right.
Okay.
All right, we ready for number 11?
Yep.
An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim was about $1,500. They are concerned that the true mean is actually higher than this. Use the information for questions 11 and 12. Which of the following would be appropriate alternative hypothesis?
I'm thinking it's the average claim amount is greater than 1,500, right?
I agree.
Yeah.
Because they're concerned if the mean is actually higher. So I think that's it.
Yeah, it would have to be.
Okay. 12 says, which of the following would be the appropriate null hypothesis? So the average claim amount is equal to 1,500, I think.
Yeah.
Sure. All right. The insurance company randomly selects n equals 4 sample mean of 1650. Is 13 to 15. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption?
Well, we gotta find it out.
Yeah, that'll probably be good to.
So how do we figure that out?
Randomly selects 40 claims and calculates a mean.
I think the answer is probably yes, just because our sample size is above 30.
Yeah,
that's true.
I'm
Because I don't know of any math thing we could do unless we have the data.
Oh yeah. That's all it is, huh? It's more than 30, right? I was about to look for the Z-score.
Yeah.
I'm good with yes.
Yeah, I think that's right. Okay.
My turn. My turn?
Your turn.
Come on.
What theorem or law justifies your answer to the previous question?
Okay, well there you go. Central limit theorem, right? Or
I think it's just the law of large numbers.
Oh, yeah, large numbers.
I don't remember. Because we're using both.
so
Yeah.
the law of large numbers, if I remember, it's the more sample means you have, the closer what their average is to the real average.
Yeah, that's right.
And then I don't know.
I think you're right. I think
I
it's.
don't really feel like we had very many problems that had to do with central limit theorem. Most of them were law of large numbers.
Yeah, I'm thinking central limit theorem is remember we were taking that test. There were two things we thought it was. It was like, okay, well, if the parent population is what is it? If it's normal, then the sample population is normal, and if the number is more than 30, I think it is, then it's also normal. I think.
Yeah. I think since we're talking about the actual distribution, it's probably the central limit theorem.
Okay. Let's do that then.
I think you're right.
You're a traitor.
Sorry. His reason was indisputable.
Whatever. I didn't back mine up. Whatever.
As I'm like,
Michael
I'm using all these wrong wording, like butchering it.
Yeah, you're out of the group. If this is wrong, you're out of the group.
Yeah, this is wrong. You're done, Mike.
All right, that's a lot of pressure. Okay, so 15
right.
is Which of the following is the test statistic? Is the test statistic as defined in this lesson? Which of the following is the test statistic?
Let's see.
I don't know. Well, there's an S for statistic.
Z
Is
What's
Z
the X with the line over it again?
That's the average of the sample. So it's just like if they give you a sample, it's
Sample
that
mean, right?
Yeah,
Yeah, that's the sample mean.
Yeah.
Okay.
Kind of the cool thing nowadays.
And there.
So let's see. It's not X bar.
Okay.
Did you?
Z, I think that's Z-score, right?
Yeah, but let's see here.
Maybe in this lesson
talks,
it's something else.
Yeah, test statistic. There it is. Oh, yeah, it says right here where Z is the test statistic, X bar is the sample mean, U is the population mean, and sigma is the standard deviation. So yeah,
Okay.
I think it's Z in this lesson.
Okay, let's do that.
And N is the sample size. So yeah, it's probably Z. I think it's Z.
Yeah.
All right. Oh yeah, we gotta do some math. The historical mean of sales receipts at a grocery store is $150 with a standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the following hypotheses. The null is that it is 150, and the alternative is that it's less than 150. She has used a level of significance of 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes X bar to be 144. What is the Z-score associated with the test? So we should be able to take...
Oh, so it's just saying find the Z-score?
Yeah, so it's 144 minus 150, right?
Yep.
Divided by... let me see.
Standard deviation of 40 over square root of
36.
Oh,
so it's 36 sales.
Okay.
So 6 divided by 6?
So it's 144 minus 150 over 40 over the square root of 36.
Oh, okay.
Divided by 40 divided by square root. Oh.
I got negative 0.8995, but I guess I would round to what would that round to?
Hey, hon, can you take this baby for a second?
What's the number, Michael?
I have negative 0.8995, but how do you round that? Because then if you round the 9 to a 10, and then that would round the other 9 to a 10. I don't know. I need to put that in like Excel or something.
That is really weird. Because that would go to a 10. And that would, so would we just negative 900?
I don't know.
So you got negative 6 over
8995. So that would go to a 10. That would go to 10. That would go to a 9. Yeah, it'd have to be 900. It's the only thing that would make sense.
Sorry.
Because you have to round up, and the 5 would have to go to make that 9 a 0, and then yeah, it would have to. It would have to be 900.
That's what I'm thinking.
So did you guys get negative 0.900?
Rounded, yeah.
Oh, rounded?
Well, because when I I did it and I got negative 0.8995, etc. But then when the 5, if we're rounding it to 3 spots, I think it rounds it to
negative 0.900.
Yeah.
I just got negative 0.9 flat as the number. So 144 minus 150, which is negative 6. And then we divide that by 40 divided by 36. I get that.
Here, wait. Let me see real quick.
I don't know if you can see that. Is that even going into focus?
No, it's not focusing for me. Yeah, that's fine. Let's go for that.
I get negative 0.9.
Okay.
36.
Negative 0.9.
That's kind of weird. I wonder why.
Yeah, I don't know.
I guess it rounds the same number you got, so.
So it's negative 0.090.
No.
Well,
should be negative 0.900.
Yeah.
Oh, that's what we had. Okay.
Yeah. So we're good.
We're good. It just was weird that I got it. Yeah. What is the p-value associated with the z-score from the previous question?
So we just gotta
get ourselves an applet.
Plug that in.
Stop. Okay, go. Sorry.
It's all right.
Sorry, I'll put that on mute. Hold on.
All good. Okay.
Where's this applet? Okay, I got p-value as 0.184.
That's what I got too.
Okay.
All right, what inference would you make about the null hypothesis from this problem?
I think it's failed to reject it, right?
Yeah. Since our p-value is greater than our alpha,
right?
Failed to reject.
Okay. So 19 is, there are 2 types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? I actually have that one written down. So type 1 error says reject the null hypothesis when the null hypothesis is true. So that's what the problem said, right?
Yeah.
So I think it's number 1 then?
Yes.
That's what it sounds like.
Okay.
Almost sounds too straightforward.
I know. Like, all right. Well,
wait, what?
Like, what now?
Are you sure? Is this a trick question?
There's more to it, right?
Yeah, so type 1 is when you reject the null hypothesis when the null hypothesis is true. Yep, that's right. Sweet. All right, a researcher decided that instead of using a level of significance of 0.05, he will use a significance of 0.01. Which of the following will be true? The probability of a type 2 error will increase, the probability of a type 1 error will increase, the probability that the null hypothesis is true will decrease, his experiment will be more scientifically valid.
I think it's the type 2 error will increase. Because I feel like there was a question in the homework or whatever that was like, you can make, if you lower it, if you lower alpha, then that helps you know that you're going to avoid type 1 error. And when you avoid type 1 error, it increases your chances of
type 2.
Type 2, I think. But I don't know if we want to look that up or.
Yeah, well, that makes sense because if you decrease the alpha, that means you're making it harder to reject the null, right?
Right.
Right.
And a type 2 error means that you failed to reject the null
When it should have been.
you were actually supposed to reject the null.
Yeah.
So yeah, that makes sense.
Okay. Because, for example, if we got a p-value of 0.02 and it really was supposed to be rejected, but we were like, no, well, we're not going to, then we'd be doing a type 2 error.
Uh-huh.
So it's the probability of type 2 error will increase.
Yeah. Hopefully.
I think so, because it's not. I don't think it's a type 1. The probability the null hypothesis is true will decrease, and that's not true, because if anything, the null hypothesis would increase.
Right.
And his experiment will be more scientifically valid. Well, that entirely depends on what the experiment is to even know if that's useful or not. So that makes sense. I'd go with that.
Okay. So then this one, is it my turn or?
Don't be trying to steal my last problem.
Sure.
Yeah, I'm sorry, man. You could have it. I don't want it.
Sigma equals 0.05. Compute the probability of computing a type 1 error.
I think it's just a 5% chance, right? Because 0.05 is 5%, and if a type 1 error, what is it? It's when you fail to it's when, gosh.
When you reject the null, but you weren't supposed to.
Right. So if our p-value fell within 0.01 to 0.05, that's a 5% chance of
Rejecting the null.
yeah.
Oh, right.
But there's no percent sign or anything, so it's kind of like.
So we probably just put in. What do we put in?
Just a 5, or is it 5 over 100? I don't know.
Or do we do it like on the test?
Do it like a decimal, right?
Oh, right. Okay. So 0.05.
0.05, right?
Yeah. Yeah. Okay. That's right.
Are we putting 0.050 or 0.05?
Oh, because it's 3 decimals.
Probably 0.050 since we do 3 on everything else.
Right,
okay.
Unless specified otherwise.
Yeah. Yeah, you're right.
I don't
It's just so weird to me to do that, but whatever.
Yeah.
Okay. So are we good? Is there anything else?
Nope.
All right. I'm good.
100.
100. Sweet.
Yay.
Nice
Yay.
work, team. Hey, you can stay in the group.
Yeah,
Good.
you got lucky, though. You got lucky.
I was starting to sweat bullets there. I was getting pretty nervous. I'll tell you. I was like, where will I go if I'm not in this group, you know?
Oh, my God.
No one else will take you. No, just kidding.
Awesome.
All right. Hey, thanks, guys.
Yeah, have a good Memorial Day.
See ya.
Yeah, you guys too.
See ya.
All right, see ya.
See ya.